Now you are aware of these two fundamental forces, that is gravitational force and electrostatic force. Now why electrons revolve around nucleus? That is because of this electrostatic force. Electrons are having negative charge, whereas nucleus is having positive charge, and therefore they revolve around nucleus. Now question is that why proton in the nucleus should repel by another proton? That is because of electrostatic force. Like charges repel, unlike charges attract, and on basis of that, this is the answer. Now imagine that there was iron nail here. Initially it was falling down because after releasing, because it is attracted towards earth by its gravitational force. But suppose I am keeping here magnet, strong magnet here, then this iron nail, by releasing out, it should not fall down, it should move towards the magnet. Why? Because electrostatic force of attraction, or this magnetic force of attraction, is more powerful than gravitational force. Now same way, in the nucleus, two protons are combining together. Reason is that there must be some greater force existing which is much more powerful than electromagnetic force. And scientists now realize this type of force must be there. They named it as nuclear force. So this way, because of this nuclear chemistry, third question or third force, to answer this, third force is developed, or we realize that there is third type of force. This is also considered as fundamental force, that is called as nuclear force. Now we realize that there is no nuclear force, there are nuclear forces. But here we can consider nuclear force is much more stronger in magnitude than electrostatic force, and therefore proton and proton get attracted towards each other. Why they get attracted towards each other? Because of nuclear forces. Practically speaking, inside nucleus there are three different interactions. The force between proton and proton, or interaction between proton and proton, interaction between proton and neutron, and interaction between neutron and neutron. Out of that, this force is considered as very, very strong attractive force, because we have this type of atom existing. This is H12. This is actually isotope of hydrogen. We are calling it as deuterium. So it is many times represented as capital D. So D12. Mass number minus atomic number is number of neutron. So this consisting of one proton and one, no, neutron should be given by small letter actually. So it is one proton and one neutron. So there is existing nature that one proton and one neutron stays together. Now here two proton, so atomic number should be 2, that means it is helium, and mass number should be 2. This type of isotope is not yet discovered as per my knowledge. Suppose you are having evidence, then all right. But two protons, then it must be helium. So this is not existing particle. But you are aware that He23 and He24 are existing in nature. He24 is stable isotope of helium, whereas He23 is important isotope of helium, but it is existing practically speaking. So here 3 means one proton is there. So in this case one proton and one neutron and 2 proton, whereas here 2 neutron and 2 proton. So when there is neutron is going to add here, then it is there. So we are considering proton neutron nuclear force is very, very strong, and it is of attractive in nature. and this way neutron helps nucleus to stabilize. Whereas two neutrons together like that, particles are not existing. Neutron remains single, and this way we can say these forces are not that strong, attractive in nature, but proton neutron forces are very, very strong, attractive in nature. We got evidence of deuterium 1-2. So this is about nuclear forces. So nuclear forces, I can say this way, very, very strong forces, or with our present knowledge they are the strongest forces, fundamental forces, even stronger than electrostatic force of attraction or repulsion. Their magnitude is very, very high, but their range is very, very low. They are coming in existence particularly when distance between two particles is less than 10 raised to minus 12 meters. If distance between two particles is less than 10 raised to minus 12 meter, then only these forces are having existence, and in order to get effective, it should be even less than 10 raised to minus 12 meter. Then only it is having effectiveness. Effectiveness and existence are different. But in order to get existence, they are having existence around 10 raised to minus 12 meter, but they are practically effective when distance between two particles is even less than 10 raised to minus 15 meters. That's why electron revolving around nucleus is not falling inside nucleus. With some exceptions, there are some electron capture reaction, but right now it is not our topic. So electron revolving around nucleus is not falling in the nucleus because that electron is revolving with greater orbit than 10 raised to minus 12 meter. Whereas if it is less than that, then nuclear forces are having existence. Now what is exact nature of nuclear forces? It is given by Japanese scientist Dr. Hideki Yukawa. I am saying again, Japanese scientist, great scientist named as Dr. Hideki Yukawa. He was able to give exact how these nuclear forces works. For that purpose, he assumed a particle that is called as pi meson is present in the nucleus. What he gave name as pi meson. Again, question is there, why this pi letter is used? For that purpose, we have to go to organic chemistry. Try to recollect benzene structure. In structure of benzene, we discuss that this ring is there. This ring is there because of delocalized p orbital. They are called as p pi orbital. Supposed to be, as we discuss in that structure, try to recollect that lecture again, that this is the probable structure of benzene ring as well as this is the probable structure of benzene ring. So here the position of bond is single, here double bond and here single. So like that position of bond is changing out. So this is also structure and this is also structure. We are calling this as resonating structure. At that time, pi orbitals are delocalized and we are showing this structure. In order to show this structure, we are showing this way. This is delocalized p pi orbitals. That gives stability for benzene, and that's why double bond reactions are not shown by benzene as it should be there. So some sort of that stability is given by this particle. So Dr. Hideki Yukawa termed these particles as pi meson. Now for lower level, we can consider pi mesons as massless particles. In higher level, we are considering they are having some mass, 200 times heavier than electron. You are aware that mass of electron is 1 by 1850 AMU. But now we can consider multiply that by 200, you will get mass of pi meson. Again, pi mesons are of three types. He says pi mesons are positively charged. That positive charge is equivalent to charge of proton. Negative charge, that is equivalent to charge of electron. And zero or neutral particle having charge that is 0, that means nothing to equivalent, we can say that is equivalent to neutron. Why we consider the name pi we discuss. Now meson, meso means coming in between or middle part. So this is coming in between, therefore it is called as meson. So pi meson. Now we discussed that pi mesons are almost, we can consider a massless particle right now. Now what happened in the nucleus? There are various reactions given by proton and neutron with pi meson. For example, pi meson can combine with positive particle. This is +1 charge, that is proton. So it is combining with -1 proton. Now this is reversibility sign. We can proceed in this direction, so this, and this direction this. So positive pi, that is proton, that is combining with negative pi meson in order to get neutron. Neutron is having 0 charge. Proton can combine with neutral pi meson to give proton only. So I may name this P1 and name this P2. That is in order to balance out masses. Whereas neutron, that is neutral in nature, can combine with positive pi meson reversibly to give proton. Proton is having +1 charge. And like that, various possibilities are there between proton and neutron. You may say that proton is there, if it combine with positive pi meson, then, but why these two should combine with each other? Because they are having positive charges, and you are aware positive repulsion is there. And so here we are not talking of this type of reaction, otherwise you will get double charge proton. So these possibilities we can consider. Every time you will get this is coming in between. So we are calling this as meson. Say, what is conclusion of all these transactions? Conclusion of all these transactions is very simple, that proton can be converted into neutron or neutron can be converted into proton. Getting idea exactly that proton can be converted into neutron or neutron can be converted into proton. Now these type of transactions are going on in nucleus continuously. Let us check out. This is proton and this is proton. Now both protons should repel each other, but the moment these two are coming in contact, this proton, let us check out this way, neutron. So this proton is converted into neutron, whereas this is remaining as proton, and you are aware there is attraction between proton and neutron. But this will decrease out atomic number, because you are aware atomic number is number of proton in any atom. So at other part of nucleus, one neutron is converted into proton. So one proton is converted into neutron, whereas at other incident neutron is converted into proton. And this way repulsion is minimized. So as atomic number increases, number of neutrons required for the purpose also increases. Say for example, hydrogen is having no neutron, one proton only, where A equal to Z. But helium is having at least one neutron, and for stable isotope 2 neutrons. Till atomic number 20, number of proton and neutrons are almost same, sometime greater by only 1. For example, sodium, atomic number 11, mass number 23. So 11 protons and 12 neutrons. But nitrogen, atomic number 7, mass number 14. So 7 proton, 7 neutron. Calcium, atomic number 20, mass number 40. So 20 proton, 20 neutron. But then onwards, neutron numbers start increasing. In case of uranium, atomic number 92, mass number 233, 235, 238. Suppose these 3 isotopes we are considering, then in case of 238, there are 146 neutrons, whereas 92 proton. So for 92 proton, there should be 92 neutron, but still 54 neutrons are more, because number of neutron 146. So this way we are getting change. Getting idea? So let us check out again. That means in the nucleus, the probability is giving in this way, that neutron proton, say this is proton, both protons should not come in contact with each other. The moment they are coming, one proton is converted into neutron. In another incident, neutron is converted into proton. Proton is converted into neutron, and like that continuous changes are happening. So suppose I am having very fine microscope, having very high magnitude, magnification power and resolution power. With that, if I am able to show nucleus as football, and I am picking out one neutron from that, I am not able to pick out, okay, this is neutron I am picking out, or this is proton I am picking out. Till that it will change continuously to proton, neutron, like that transactions are given. And that's why now we are considering these particles as nucleon, the member of nucleus, that is called as nucleon. So rather I should call as proton or call as neutron, I should call as nucleon. So I am revising again, it is proton, neutron, no, what I should call them as nucleon at higher level. So this way we have first part, that is nuclear stability, explain on basis of nuclear forces, and for that purpose we introduce here a particle that is named as meson. So there are 3 pi mesons, one is positive, one is negative, and another is neutral. Okay, this is explanation of nuclear stability with respect to pi meson concept. Now we are switching over to energy concepts.